Hi everyone, we're going to take a few minutes today and talk about how to find a confidence interval for a mean. And there are 2 or 3 different scenarios that we need to talk about. The first scenario happens when we know sigma. Sigma is the population standard deviation. This hardly ever happens. This only happens when you're dealing with data that is something like height, weight, BMI, IQ, something that you already know a whole lot about. The other scenario happens when you're dealing with sample data, where you would know the sample standard deviation. And in that case, sample size matters. And when sample size matters, you really need to have 30. One of my students made me this super cool mug one time. So anyway, that is important. So we're going to do a few problems. If you would, go ahead and pull up your calculator. And the one that we're going to be using is confidence interval with statistics. And then we're going to do confidence interval with data in a minute. And if you look over here at the top, it has like sigma unknown, sigma known. So the first one we're going to do is sigma known. So construct a 95% confidence interval for the true mean SAT score if we have 125 SAT scores. That would be N. So N is 125. The mean is 1122. And our known standard deviation is 150. So that is like sigma is known to be 150. And now we're going to do this confidence interval estimate of our mean SAT score. Okay, here we go. Sigma is known, so make sure you check that first. We have 125 in our sample. So we get like 1095.7 to 1148.2. You can't have part of an SAT score, so round it off till it makes sense. So we'll call that 1096 to 1148. 1096 to 1148. 1096 to 1148. The mean was 1122. The mean is our best point estimate. If you want to know what your margin of error was, your margin of error is like how far off you are from either side. So if I were figuring out my margin of error, I would say 1148 minus, that's a 4, minus 1122. So that's really like plus or minus about 22 points. And you could subtract it the other way too. You could say 48 minus 1096, and you'll also get plus or minus about 22. So you're trying to figure out about how much it is off from the middle. Okay, let's talk about constructing a 99% interval. Leave all your data in your calculator, go back. Just change this to a 99. Let's see what happens. Okay, 1095, 1048. Now it goes from 1087 to 1157 or so. 1087, 1157. Okay. 1087, 1157. Okay, the 99% is wider, and I'm going to show you why. Okay, look at the board. Okay, if any of you do target practice, pistol practice, bow and arrow kind of practice, think about this as being like a bullseye. Okay, and let's say that you're pretty good. Maybe you can hit the bullseye like 90% of the time. It's this big. Okay, maybe you can hit the next one like 95% of the time. It's this big. Maybe you can hit the whole target 99% of the time because it's as big as like the broadside of a barn. It's even bigger. As your confidence interval gets bigger, the confidence level gets larger. 99, 90%, 95%, 99%. Okay, so that's how that works. Okay, let's move on. Okay, second example, we do not know the population standard deviation. We have a keto diet. A keto diet, that's like that Atkins kind of diet where you just eat meat, where you don't have bread, where you don't have carbs, where you don't have any joy in your whole life for a while. So 40 individuals participated in this. So we have 40. After 12 months, the mean weight loss was 2.1 pounds. So they did lose weight. They lost 2.1 pounds in an entire year. Okay, the standard deviation was 4.8. That's the sample standard deviation is 4.8. And we're doing a 99% confidence interval. Okay, so this time sigma is unknown. We have 40 individuals. Mean is 2.1. Mean weight loss was, or the standard deviation was, mean weight loss was, or the standard deviation is 4.8. 99% confidence interval. Okay, lower bound is 0.04 and upper bound is roughly 4.2. 0.04 to 4.2. Okay, let's think about that. Just like wrap your head around it. Okay, 0.04 to 4.2. 0 would be losing no weight at all. 0.04 to 4.2. 0.04 pounds to 4.2 pounds. So is it effective? Did they lose weight? Is it more than 0? Yes, it is more than 0. Is it practical? No. Would you quit eating pasta, ice cream, suck all the joy out of your entire life for a whole year to lose somewhere between 0.04 and 4.2 pounds for a whole year? No. So, this is an example of just because something has statistical significance does not mean that it has practical significance. And people will do stupidness. They'll do all kinds of tests and they'll go, well, this is statistically significant. And you want to look at them and go, does that even make sense? You know, so always go behind your work and ask yourself, does this make sense? Would this make sense to actually put into use in my company? You know, should we spend money on this project for this amount of profit? Okay, next. Okay. Oh, I didn't list the weights. It says below are weights in pounds of glass discarded in 1 week by randomly selected households based on this garbage project in the University of Arizona. Ideally, how many would we want to do this test? We would want 30 because sample size matters. Okay, I forgot to type it on these notes, so instead we'll just go over here and just type these in together, and I'll show you how to do this. Okay, so go back to your calculator menu, go down to the one that says confidence interval for a mean with data. Okay, mean with data. Okay, I'm going to find my data. Okay. So I found my data, and let's just enter these together. So I had 3.52 pounds, and you enter each one of these with a comma. 3.52, 8.87, comma, 3.99, comma, 3.61, comma, 2.33, comma, 3.21, comma, 0.25, comma, and 4.94. Okay, don't put a comma at the end. It will yell at you. And we're going to do this as a 95% confidence interval. We don't need a mean. We don't need a standard deviation. We don't have 30. So I said we had to assume that they had been doing this project for a lot of years, that it was normally distributed. Otherwise, you're out of luck and you have to do some kind of non-parametric statistics, mumbo jumbo. It's just easier to go back and find more households. Okay, calculate. So we get between 1.79 and 5.89 pounds of garbage. So if we were saying this, we would say, we are 95% confident that the true mean weight of garbage in Arizona, we're 95% confident that the true pounds of glass discarded is somewhere between 1.79 and 5.89 pounds. We are 95% confident that the true mean weight is between here and there. We would not say things like 95% of the time they discard between 1.78 and 5.89 pounds. We would not say there's a 95% chance that happens, because, like my mug says, no chance. We don't ever say chance. Okay, this is a confidence interval, so we talk about confidence. We could figure out the margin of error by taking 3.84 and subtracting either the upper or lower bound. You could also do the upper and lower, divide it by 2, and subtract those and get your margin of error that way. Okay, so I hope that helps. And again, always reach out to me if there's anything that I can help you with. And I think these are kind of cool. One last thing. If you are doing this on a different software package, this would be called a T interval. Z intervals are the ones where you know sigma. T intervals are the ones where you don't. Okay, have a good day.